All right, so we're gonna do a couple practice problems here for absolute value functions and their transformations. So when it comes to these problems, I'd say your first step should most always be finding the vertex first. So how do we do that? Well, first step is to look at this here, this x portion, and we want to find what value of x is going to make this 0. So in this case, it would be 3, because it would be 3 minus 3, which is 0 plus 7. Now, if we plug in f of 3, and we know this portion equals 0, but this 7 will stick around because there's no variable connected to it, so our vertex is just 3, 7. So it's kind of a starting point, 3, 7. Now, to kind of visualize the rest of this function, you can do it one of two ways. There's the longer way, which is plugging in values one by one. So for instance, if we were to look at, the next x value, which is 4, and plug in 4, we would get 4 minus 3 plus 7, which would be, 1 plus 7, which is just 8. And let's say we did it for 2 as well. F of 2 would be 2 minus 3 plus 7. Now note that this would be -1, but the absolute value sign is actually going to make this just 1. So 1 plus 7 is 8 as well. So our function will actually look like this. Okay, so the other way to do it, and the much quicker way, is to simply look at the x variable, see that the only number out front of it will actually just be a +1. So the slope is just going to be +1. So, this is a +1. And if you were to, essentially do a symmetrical flipping of that, it would also be, 1 in that direction. That's true for all absolute value functions. And it's probably the quickest way of finding that. And now, in many instances, you may be asked to write, describe the transformation that this function went under. So let's remind ourselves of what the parent function would look like. So if we were to have the parent function would be f of x equals the absolute value of x. So this actually is going to look like this. I think you can convince yourself of that if you were to plug in some numbers. And essentially, we want to describe, what did they do to this function that made it look like that? So I think probably the easiest way to think of this is to compare our origins. So we have 0, 0, and then, of course, our new vertex, which we found just before, 3, 7. So just comparing these values. So the x increased by 3. So if we think about this as like a numbered line, we moved to the right 3. So we horizontally shifted. By 3. So same thing for y. We went up 7, so we vertically shifted up 7. So rather simple.